Welcome back. And now we are continuing with the other example 2 concerning with the formation of, like they have given us now the roots of the equation are here, of this equation which is the same as the other equation, and they are saying that they want us to express this one times this in terms of P and Q. We say the first thing is to do here is to write the roots in terms of now P and Q by getting the sum and the product from the equation. We say the first compare this one with the original equation, of which here, from here that the x squared plus px plus q equals 0. So we compare it with compare with what the general equation is, which is x squared minus the sum, then x plus the product must be equal to 0. So we are comparing this with this. We said here when we are comparing, we did also with the signs. Before the signs are clear, on the general equation there's a minus the sum. So here when it is a positive, you write the sum as the alpha plus beta to be equal with the negative p, then alpha beta to be like a q. So now after getting the sum and the product in terms of the roots which they gave us, then we have now to express this one. So we are expressing alpha plus, it is alpha minus 3 beta, then times beta minus 3 alpha. So we are expressing this one. Expressing means that we are going to expand this so that we can get a component in terms of alpha plus beta and alpha beta, so that we can substitute in the values P and Q. So from here we have to multiply as usual. We said we get this one, then we multiply with the whole of this bracket, which is beta minus 3 alpha. Then here it is minus, we maintain it, minus 3 alpha. Then we now multiply with the whole bracket again, which is this is 3 beta, not 3 alpha. It is this one, 3 beta. Then multiply with the whole of this thing, which is beta minus 3 alpha. So this one and this one must be the same, which you are multiplying with. So then we open now the brackets. So opening the brackets, we have this one times this, which is alpha beta. This is alpha beta. Then this one times this, which gives us minus 3 alpha squared. So now we are this side negative c times a beta, which gives us minus 3 beta squared. So then this one times this, which gives us plus 9. So c times c is 9. So times this one, which is alpha beta. So now after expressing that one in terms of alpha and beta, we have now to continue we are continuing by just collecting like terms. Like those one with alpha beta and alpha beta, bring them together. So like this one, it is going to come with this. So here it becomes alpha beta, then bring this one plus 9 alpha beta. So now we are bringing now the one which are squared. So now it becomes minus 3 alpha squared minus 3 alpha minus 3 beta squared. So now after writing that one and the collecting like terms, so we are saying that this one and this one, they have the same component of alpha and beta. So what we do, we are going to add this one. So this one we are going to get 10. When you say this one plus this is 10 alpha beta, then minus. So here we factorize out the common, which is a negative 3. So negative 3 into alpha squared plus beta squared. So that when I multiply back at the negative 3, I can get something which is the same as that. So we said that you don't leave your answer like this. You have to express it, to break it into the form of alpha plus beta and alpha beta. So you have to express this one. So we say this one can be got from alpha plus beta, but the whole thing squared, which we said is giving us that alpha squared plus beta squared. Then here it becomes plus 2 alpha beta. Then we said here we don't leave it like this, but because we need to create something which we can substitute in this one, where we have this one as a subject, so that we can substitute it, which is in form of alpha and alpha plus beta. So now what we do, we make this one the subject. We said by making this one the subject, we just take this one the other side. So for that case, it will be alpha squared plus beta squared, which will give us the other thing, which is alpha plus beta, the other thing squared minus 2 alpha beta, by taking this one the other side. Then after that one, we have to substitute it back here. Substitute it back here, what do we have? We have that the other expansion alpha minus 3 beta, then times beta minus 3 alpha. This one will give us that it will be 10 alpha beta, then minus 3. You put in now the value which you have got, this one, which becomes, now I'm going to multiply, I'm going to do it at the same time, just multiplying by negative 3, and also substituting at the same time I will have 3 alpha plus beta squared. Now after putting this one also, there is this one, so now it becomes a plus because this one was initially a negative. So multiply negative times a negative, get a positive, so which will give us 6 alpha beta. So I think everything is being expressed in terms of what we had here, which is alpha plus beta and alpha beta. So we can come here and substitute. So this one become 10q minus 3 into the value of alpha plus beta, which is negative p, but squared. Then plus 6 is the value of alpha beta, which is a q. So we said that when we square a negative value, we get a positive. So, and we are saying that this one, they are the same. So we can just say this one plus this, you get 16. 16, then minus 3p squared. Since this one we change to a positive. So we shall have something like this. So, and here they say that after expressing it in terms of p and q, they say deduce. We said that in the other previous example, we said when they say deduce, they say from where you have stopped, that's where you begin from. Like now we have stopped at this point, so we are going to deduce. We are saying that deduce that for one root, we said they say if they say for one root and they have said that the roots of the equations are alpha and beta, we say for one root, we say for instance if you take alpha, that means for one root, if alpha is just one root, it must be 3 times the other root. So this is the first root alpha, the other root is beta. So we said for this case, you bring the 3 beta the other side, so you have alpha minus 3 beta, which gives us a 0. So we have something like this, so you put it in bracket. Also, remember we are considering two roots. So if this one is 3 times beta, also beta can be 3 times the value of alpha. So for that case, here it becomes beta minus 3 alpha, which gives us also a 0. So now after getting that one, they say deduce for one root to be 3 times the other, that they want us to show that p squared to q equals 16 to 3. So this one, they mean, this, where you find something like this, where you find something like this, that is p squared minus q, it is p to q. This one means it is, we are dividing p squared divided by the q. So this one is a ratio. So they want us to prove that this one equals this one. So how do we prove that? From here we have seen that for it to be 3 times the other, it is going to be like this. But also we can, from here we can just multiply this one, then we equate to 0. So for this case it will be alpha minus 3 beta 10 times beta minus 3 alpha. So this one gives us a 0. So for this case, we have reached at this point, and we know that because they say they deduce, so from where we stopped. And where we stopped, we had something like this which we expanded, which resembles this one. So that means the answer which we got is what we are going to substitute here. So the answer which we got was this one. So we have to substitute in this expression which we have to get what we need. So for this case, it will be 16 minus 3. This is 16q. 16q minus 3p squared, which gives us a 0. So we are here, we are deducing. We are starting from where we stopped, which is this point. So we substitute in this one. So by doing this, I'm going now to take this one the other side. The negatives here, bring it this side. So it becomes 16q equals 3p squared. Because when the negative crosses an equal sign, it becomes a positive. So for that case, I have now to divide both sides by 3. Remember, with a p squared this side. So divide by 3. So I have here 16 out of 3q equals p squared. But we need something in form of p squared out to q. We said that p squared to q is the same as saying p squared divided by q. So what comes here, it is just dividing both sides by q. So divide by q, so that we can come out with something like this. So that means here our p squared out of q is the same as 16 out of 3. So having reached that step, we have seen that this one is equal to this. And here we have seen that clearly that when they say p squared to q is the same as saying p squared divided by the q. So here then you say this one is the same as p squared to q is the same as, so what we have done this side, also do it in the other side, so which will give us 16 to 3. So if you take on the question what they gave us, it must be the same as this. So that's how you can prove that. I think everything is done. So thank you.